Still got some people trickling in, so I'll give them 10 seconds. We'll watch them run. 9, 8, 7, 6. Man on the door is itching to close by the looks of it. All right. Welcome, everybody. I am back in Australia for a very brief amount of time to come and talk to you good folks about ASP.NET Core. Anyone here who was in the workshop the last 2 days? Just a couple of hands, good. We had good fun teaching ASP.NET Core Introduction workshop last 2 days. We've been doing that at the various NDC conferences. We did it a couple more places in the US as well. But today we're going to go down just another layer deeper. So it's called ASP.NET Core Deep Dive. My name is Damian Edwards. My Twitter handle is @DamianEdwards if you want to ask me questions or talk to me in the future or berate me or whatever it is. For today's deeper dive, what I decided to do was, often when we do an overview of ASP.NET Core, we kind of run through a very high-level sort of overview of all the various subsystems that we introduced in ASP.NET Core, because there's a lot of new API. We kind of reinvented a lot of the basic primitives, configuration and logging and dependency injection and startup code and middleware and then routing and MVC on top of that, and then Razor has a whole bunch of new stuff. So today I wanted to kind of go to the next level down, rather than picking one thing and diving really, really deep, which can be great for a geek out, but perhaps not as potentially useful to you in your day-to-day jobs. Today what I'm going to try and do is I picked sort of 5 or 6 areas that I would choose to go to one or two layers deeper than perhaps you've seen in the past to help you get a better understanding of how it works, or in some cases to show you some API that perhaps you hadn't come across yet, you hadn't seen us talk about yet, or maybe you saw it in the template, you didn't really understand how it worked, or maybe it's in the template and you haven't even noticed it's there. So without further ado, well, I've only got about 57 minutes now, so let's see if we can't dive through as much of these as possible. I'm going to try and leave a little time at the end for questions too, hopefully. We'll see how long I ramble for, but there will be a mic at the end so we can do some questions at the end. So the first thing I want to talk about is .NET Core, ASP.NET Core, .NET Framework, portable apps, standalone apps. These are terms you might have heard before, some of them, maybe not all of them, and how these things compare to each other. So if I do a new ASP.NET application, and I'll choose, in fact, if I go back to the previous screen, the first thing you'll note is when I choose a new ASP.NET Core application from Visual Studio, there's a couple of templates here that look very, very similar. And you have to kind of squint and look a few times to see the difference. So I've got ASP.NET Core Web Application for .NET Core, and then I've got ASP.NET Core Web Application for .NET Framework. So one of the big things of ASP.NET Core is that it will work on .NET Core or .NET Framework. Okay? It works on the core CLR with core effects, which is what gives you cross-plats and gives you side-by-side frameworks and the ability to deploy the framework inside the application. But it also works on the .NET Framework that you know and love. In fact, we released a new version of it this morning. .NET 4.6.2 hit the wire this morning with a few new features. But .NET Framework is .NET Framework, right? It installs in Windows. You can only have one version of the machine at a time, et cetera, but it has a lot more API, and every DLL that you've ever used in .NET will pretty much load on .NET Framework as opposed to .NET Core. So what is the difference here? Well, let's start out with .NET Core, because even if we choose .NET Core, a couple of things, there are a couple of differences even just within the scope of .NET Core itself. We'll forget about .NET Framework for a minute. We'll come back to that in a very short period of time. So when I run one of these applications, we will wait for my VS to restore packages. I was told the internet was really good in here. I'm going to run this application. I'm going to start Process Explorer. No, it is there. Don't lie to me. I'll just do it manually. OK, so we'll pin this over here. So my ASP.NET Core application is running. And over here on the left-hand side, if I scroll all the way down, when I run from Visual Studio, we're going to see a whole bunch of stuff going on. So here's devenv.exe. Goes through this thing called, well, we don't care about that. What I really care about is .NET.exe. So here it is. Here's .NET.exe running. That's not the instance I particularly care about, though. I'm going to find, there it is, the one with IS Express underneath it. Oh, it's jumping around. Don't do that. So devenv.exe, which is what I just launched. This instance of .NET.exe is if I hover over it, you can see the command line arguments. It's saying project model dash server, okay? So that's a special instance of .NET.exe that drives the IntelliSense for your .NET project, so that's not the one we're interested in right now. What I'm interested in is this one all the way down here. This is the one actually running my application. You can see the arguments being passed to here include a DLL name, which is the name of my application. But above that, we'll see a couple of other executables that were launched before it. So I can see IS Express because I'm running on IS Express at the moment. IS Express then launches this special thing called the VS IIS exe launcher, which we'll talk about in just a minute. And then finally, it launches .NET.exe pointing at my assembly. Now, if you've ever used this from the command line, you will know that there's a command called .NET run, right? And so I can do the same thing rather than doing it from VS. I could go to this location on disk, wherever it might be. I can bring up a new console window. And just this lovely long path right here. And I should be able to write .NET run. Maximize that so we can see it. Oh, and it fails, probably because I still have the process running, so it can't build it. So exit that. Let's do it again. OK, so what did .NET Run do as opposed to what VS was doing? Well, .NET Run checks the source of my project, in this case, a bunch of C# files. It decides that it has to compile it because it can't find some outputs in this case, or it's changed since the previous compilation. And then it goes off and starts .NET.exe for me, which is the host of .NET Core, and points it at my application. Well, where did it compile to? Now, none of this is particularly different to where you might have done it in the past, but given the history that we went through with ASP.NET 5, and then ASP.NET Core, and DNX, and then to .NET Core, a lot of this stuff did change along the way. So if you haven't looked in the past, or perhaps you looked in the Beta 8 and RC1 timeframe and you haven't looked since, some of this may be new to you. So this is very similar to how things used to work now. Okay, so inside my project, underneath the bin folder, I have debug. I have a folder now for this thing called NetCore app 1.0, which I'll talk about in just a minute. And then inside this folder, here's my actual DLL. So yes, when you .NET Run, you're still compiling the application. It does it for you behind the scenes. It's not magically using Roslyn to do things in memory like we tried to do in DNX. It actually ended up causing a bunch of problems. And so we're back to sort of doing things the traditional way, but the .NET Run command takes care of figuring out whether you need to recompile before you go off and run the application again. Okay, so you still get that nice experience if you're at the command line of make a change, .NET Run, then go off and run the application if necessary. But where's the rest of .NET? So I mean, you can see here the only thing in my output folder is my application, right? If I was to do this in an MVC5 application, there'd be a whole bunch more DLLs in here. Specifically, there'd be all the DLLs from the NuGet packages that I referenced. And I can see some heads nodding going, yeah, I kind of expected to see a lot more things in here. Well, that's because the .NET exe, the .NET Core host, has the ability to load assemblies from your NuGet location. Okay, so when you're doing development like this, you don't have to copy all those binaries from the NuGet location into the output location. And all that information is stored inside these special JSON files. So if I open this JSON file up, these are JSON files that are read essentially by the CLR host. Okay, they're read by the native code that boots the .NET Core CLR and then tells it which assemblies to load. And so inside here, you can see already, right? Here's a bunch of stuff down here about the dependencies on my application. And if I search for .dll, you can see my DLL, which is all good and well. But you can see we're starting to see other DLLs in here. Net Standard 1.3, Microsoft ASP.NET Core, anti-forgery. So these are the DLLs from my NuGet location, which are being loaded by .NET Core when I run my application. Now, this is just during development, though. This is just my bin folder. Okay? This is not what happens when I publish my application. What happens when I publish my application? So if I go back to the command line and I publish this app, and it doesn't like, oh, that's interesting. Apparently, I haven't installed Barrow on this machine. And we'll all wait while npm runs. At least it has this nice ASCII art progress bar now. While that's doing that, I'm going to change my font settings here. See if I can't fit everything on the one screen at the same time. That's a little bit better. And I'm going to get impatient here, so I might have to go back to VS and let it do it for me. Let's have a look. Come on, come on, come on, come on. 1, 2, 3, okay. Let's see if we can do this the old-fashioned way. To the disk, please. And I will go to this folder, that's perfectly fine. I'm going to choose Netcore app because it's the only one I'm compiling for, and I'm going to go ahead and hit publish. And we'll see if VS beats my command line. I wonder if I can cause some type of race condition. No errors, command line's winning, command line's win, command line won. Oh, that's pretty sad, isn't it? All right, so I've published my application now. Let's go and have a look at the publish output. So by default, because I didn't give it a publish location, it shoves it in a subfolder of the bin folder called publish. And if we look inside this folder, we're going to see quite a lot more files than I saw before when I compiled the application, okay? So the difference between .NET Build, or building in Visual Studio, or .NET Run, which calls .NET Build for you, and .NET Publish, is that Publish is creating, this isn't fully standalone yet. This is what we call a portable .NET Core application. This is one that I can take the Publish output, move it to another machine that has the .NET Core SDK, or the .NET Core Runtime installed. I have to have .NET Exe on that machine, and then I can run it, okay? Because it has all of its NuGet dependencies copied in to its bin folder. It's quite a lot bigger, as you can possibly imagine. Now, there are some other interesting files in here too. There's this refs folder. Has anyone seen this in their publish output and wondered what this was? Yeah. So this is to allow MVC to do runtime discovery and compilation for you. So think about how MVC works, right? You compile your controllers and your C# code up front, and then you build your application, you publish it, and then when your application starts, MVC has to go, right, I need to find controllers. And in order to find controllers in ASP.NET Core, what it does is says, load me all the assemblies that are in the application and find all the types that reference MVC. And then of those types, find the ones that look like controllers. Now, in order to do that type of stuff at runtime, you need to maintain a bunch of the information that you had at compile time. Okay, remember, there's two distinct phases here, compiling and then what happens at runtime. Secondly, MVC has Razor. And Razor CSHTML files get compiled on the server. They don't get compiled when you do Control-Shift-B in Visual Studio or .NET Build. They get compiled when your application starts. And for Razor to have access to the same APIs, or your views have access to the same APIs that your C# code does, we need all those same reference assemblies, those same APIs available when we invoke the compiler when the server starts. So that's what this refs folder does. And that is controlled by this new property that you may have seen in Project.json. If I go to the build options section down here, this preserve compilation context. That's what that does. That preserves all the information to do with compiling your application into the output of the application, so you can do more compilation when your application starts. Okay, you can do Razor compilation. Now, incidentally, for those wondering where Razor pre-compilation went, we're working on it right now. It's going to ship in 1.1. Okay, and the advantage of that is you don't have to pay the cost of compiling your views when the application starts, which means your application starts up that little bit quicker. Okay, so this application is portable. That's what I called it, a .NET Core portable application. Well, how does that work exactly? I am seeing a bunch of stuff from NuGet in here, Microsoft ASP.NET Core, Microsoft extensions. I am not seeing very many system.dlls. In fact, I'm only seeing, 8 or 9 of them here. So where are the rest of those DLLs? Where is the framework? Where's .NET Core? Well, it's not in my application yet. It's over on my hard drive in program files /.NET. So over in program files /.NET, there's .NET.exe. That's what I've been running at the command line. That's what Visual Studio is launching. It's a very small native application. How big is it? I think it's only like 200, 400K or something like that. 124K. It's even smaller than I thought. Okay. And then the actual runtime is in this special folder called shared. I don't know why it's called shared. It's called shared because it gets shared amongst multiple apps, I guess. So this might be a string that you're familiar with. We'll show you where that is in a minute. Microsoft netcore.app. Inside there, we have versions. So here already is one of the big differences between .NET Framework and the .NET Core framework, because this is kind of like a mini .NET Framework, right? Is that I can very easily have multiple versions of them side by side. If we think about where .NET Framework is on your machine, where's the .NET Framework? Anyone know? Windows, Microsoft .NET, right? Framework 64. These are the only side-by-side versions I have, right? And that represents 15 years of releases. And so they're not really that side-by-side, because when did this one come out? 2010? So we haven't had a side-by-side release since 2010, okay? So that's a really big difference, obviously, between how .NET Core works and how .NET Framework works. And then inside this .NET Core framework, now I have a bunch of DLLs, okay? There's no GAC, there's no other location. This is where the .NET Core framework is. And you can see in here, there's some pretty telltale signs. I saw MS Core lib flash by, there it is, okay? But we also have some other things in here. Look at this. There's libuv, okay? That's the native library that ASP.NET Core uses, specifically the Kestrel server, in order to do cross-platform asynchronous I/O and networking. So we have things beyond just the typical .NET stuff inside this shared folder. And why is that interesting? Well, if I look at the size of this folder, this is 70 megabytes, okay? And this is platform-specific. This isn't just managed code. There's native code in here as well. This is .NET Core for Windows, specifically for Windows 10 x64. Okay? Because once you get out of the world of managed programming, you have to start thinking about what processor architecture am I on? What operating system am I on? And it's not as simple as, am I on Linux, for example, now that we support cross-platform. If you're on Ubuntu, Ubuntu 14 is different to Ubuntu 16. Okay? You can't just take something that was compiled for Ubuntu 14 and run it on Ubuntu 16. It might work, but a lot of the time it doesn't. They are treated as distinct platforms. Windows is fairly unique in its ability to say, I have something that was compiled for Windows 95, now just run it on Windows 10. Okay? It's actually pretty amazing that they make that work. In the Linux world, that's typically not how things work. So I have this nice copy of the .NET Core portable shared stuff on my machine, which is what enables my application to have a lot less stuff in its output. Okay? And I can still get the benefit of side-by-side versions. You can see I have both RC2 and the final 1.0 here. And when 1.01 comes out and 1.02 and 1.1 and 1.2, I can have those side-by-side in here. And applications can choose which version of the .NET Core runtime they want to use. Well, how do they do that? If I come back to my application and I scroll up here, you will see this entry, Microsoft.NET Core.app. Type is platform. Okay? This is a new instruction to NuGet, essentially, and to the .NET Core toolchain that says, this is a special package that represents a little .NET Core framework, okay? The thing I just showed you on my hard drive. By declaring it as type platform, when I publish it, please don't put it in my output folder, because there's 70 megabytes of crap in here, okay? I don't want this in my output folder. I'm going to just assume that it's already on the server where I'm going to deploy to. Now, having said that, if I do want to take the entire runtime with me, because that was one of the features, right? We had that in DNX and we have that in .NET Core. How would I go about doing that? Well, that's what we call a standalone application. And I will apologize up front, this experience isn't that great right now. But I'm going to show you how to do it. So first of all, you have to say, I don't want this to be a platform anymore. Just treat it like any other NuGet package. Now, this is a meta package. It actually contains references to many dozens of other packages and includes not just managed code, it includes all the native code that's required to make this work. So if I have native code, I have to tell NuGet, and I have to tell the .NET Core toolchain, what native platforms do I support? Otherwise, it's not going to know which native implementations to pull into my application. And we do that using the runtimes section of the project JSON. Now, anyone done UWP development? One hand goes up in a room of many people. No comment. So I have to tell the toolchain what versions of anything I'm going to run. Okay? And this is required so that it can figure out where those native implementations are going to go. Because libuv on Win 10 is different to libuv on Mac OS X. So I'm running on Win 10 x64, so I'm just going to say Win 10 x64 right now. When I do that, I can now start publishing with the application together. Now, I've changed my project JSON, so it's doing a restore here. My lock file is going to be a little bit different. If I come up and I do a publish again, we will see, I can do this from the command line or I can do it from VS. I'm going to go back here and change some things. So in my settings, note now that I can choose runtimes. Now, I only have one, so it's not particularly interesting. But before it said any, because I didn't supply one, it assumed that the output type was going to be portable. okay? Which means that, well, this app will run on any runtime. It's a portable app, okay? I can put it anywhere that .NET Core is installed, and it's going to go and run. Now, it's actually saying it's only going to work on Win 10 x64. So if I publish it this time, and I should have done the little race from the VS again, shouldn't I? From the command line, because I know it's quicker. Runs MS deploy is the last step. Okay, so that published. If I go to the output, you can see this, or you can see already this is looking quite a lot bigger. And I'm going to do this over here because I really don't want to look at it in Visual Studio. So I have quite a lot more files than I did last time, including MS Corelib. So you can see I have the entire runtime. And incidentally, I'm going to need some way to launch this application as well. So what happens as part of this process is that it builds you an executable, right? You know when you run your application, you type .NET Run or .NET assembly name? When you publish the entire runtime with you, it copies .NET.exe into your output folder and renames it to Web Application 25. That's just .NET.exe. Okay? It's nothing else. They just rename it for you. All right? So now, in theory, I have an output folder. I can just hit Enter on that, and it's running my application on port 5000. Okay? This is a fully standalone application that has its own version of .NET. What's the impact of that? Well, this isn't too bad. It wasn't the full 70 meg. I ended up with about 53 meg. Okay? So, as I said, the experience isn't as great as it could be. And one thing that we're looking to do in the future is to make this as simple as saying something like .NET publish -- standalone. And then it would just do everything I did just then, like editing my project JSON file, changing .NET Core app to blah, 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 blah. And it would just be a publish concern rather than an app concern where you have to actually change your application files. Okay, well, what about full framework? Well, full framework is very similar, actually. If you build for full framework, obviously it's portable because that's what framework apps are. They run on .NET Framework that's inside your Windows folder. And you get an exe in the output because when you run on full framework, you're just building a console application. Okay? Everything for ASP.NET Core is always self-hosted. You're always running inside a console application. So that's pretty straightforward. All right. Let's have a quick look at how the reload while development works. So people may have noticed, I'm going to create a new app because goodness knows what I've done to this one now. I'm going to create a new application here, and we'll make this nice and simple. We'll do one of these. We'll do an empty application. We'll come out here. One of the features that people really liked in DNX in ASP.NET 5 before we renamed it was the ability to, once the application was running from VS, just make a code change and go back to the browser and reload, right? We used to talk about in-memory compilation. The dirty truth is the fact that it was in memory had nothing to do with that feature, okay? That's just how we chose to implement that feature. The truth is that feature still works. If I run this empty ASP.NET Core application, which currently says hello world, and I put that over on the right-hand side of the screen, okay? So we can see that here. I can zoom in a bit. I can come over to Visual Studio right now. I can change this to Hello Sydney, and I'm just going to save it, right? I can come back over to the browser and hit F5, and a couple seconds will go by, and it will say Hello Sydney. So that feature still works, okay? Even though we moved to .NET Core, it's just that it works a different way, and it's not quite as fast as it used to be, unfortunately. Now, I alluded to how this works a little bit previously. When I opened Proc Explorer before, you might have noticed that if I find the right instance of dev.env.exe, which is down here, IIS Express isn't launching .NET.exe directly. It's actually launching this thing, the VSIIS. I have real trouble saying this exe name. VSIIS exe launcher.exe. This is a little shim executable that sits between IIS Express and your application, or .NET.exe. And this is the thing that we use to coordinate, oh, you changed your code, I need to recompile the application, okay? So that's great, but what if I don't want to use IIS Express? Because we support running on any server, right? In VS, I can come up to the drop-down box in my launch window and drop this down and say, just launch Web Application 26 directly, right? Just launch it as a console application. Now if I hit Control F5, I'm going to get a console window, and you're going to see it starting on port 5000, which is our default port for Kestrel, and now it's running on port 5000. But if I go and change this back to Hello World, and I try and hit F5, nothing's going to change, okay? Because that capability is unique to the VS IS Express launcher. So what do you do if you want to use a command line focused approach and still get that capability? Well, we have a tool called .NET Watch. Has anyone used .NET Watch? No one. One, two, one hand. Okay, this is worthwhile showing them. So I can come to my project JSON file, and I can pull in this tool. So Microsoft, in fact, I think I can just type Watcher, see if the IntelliSense is going to work for me today. Come on, saves me a bunch of typing if you can. Okay, we'll do it the hard way. .NET.watcher.tools, I think it is. Is that the one? And what do you do when you need to figure out where something is and you can't remember it and your IntelliSense isn't working? You go to your user profile, you go to the NuGet folder, you go to packages, and you type watch. And you go, there it is, Microsoft.NET Watcher.tools. That was correct. Okay. And then I do 1.0.0-preview2-final because the tools are still in preview, and this is considered one of the tools. I have to force a restore here because of a bug, unfortunately, in the current tooling, whereby if you edit the project JSON and just change the tools section, Visual Studio doesn't recognize that as a need to refresh NuGet, so I have to do that manually. Okay, so now I have this .NET Watcher. If I go down back into the console here, let me first show you how we'd run this from the console. So I'm going to paste this in here. So now I'm inside that. I can do .NET Run. That's effectively what what Visual Studio is doing for me. And again, I have to kill IS Express. You love how it shows in the middle of the screen. Very helpful. Okay, so there's .NET Run running, and I have address already in use because I still have the console window opening as well. Web development. There we go, so that's running fine. But I now have this .NET Watch tool available to me as well. Okay, so .NET Watch says, hey, yeah, you can run this application using .NET Watch now. So I'm going to say .NET Watch run. And now the application is running just like it was before. I should be able to go to the browser and hit F5, and sure enough, it's working. Hello world, because I changed it before in the demo. So if I want to go ahead now and change that code, I could do that. So I come over here, change that code back to, I'm going to pin this to the right so you can see the console kind of react, right? So I'm going to say, hello, Sydney, and save it. And you can see on the left-hand side, it detects, says things about, I detected your code change, so I restarted the application for you. So if I go back to the application, hit F5 now, you can see that that's updated. So how would I go about, I mean, this is nice if you're working from the command line and using something like VS Code, but I'm working in Visual Studio. So how do I hook those two things together? Well, I come back to my application. Let me kill that one over there. One of the new features we have in the web project system is a thing called Launch Profile. So I'm going to go to the project properties, and I'm going to go to the Debug tab. And you can see here we have profiles. We have the two that were created for me automatically, IS Express and Web Application 26, but you can create your own. And there's a bunch of settings you can set in the profile. This is where we store what URL to launch on. If you want to set specific environment variables or change the working directory, you can do that. So I'm going to create a new profile called .NET Watch, and this lives with the application. Okay, this is not global. This actually gets saved to a launch settings.json file in your project, and that would get checked in generally, and then everyone on your team would be able to take advantage of these settings. So I'm going to say I want to launch .NET, so I'm going to say program files /.NET/.NET.exe, and I have to pass in watch and run, which is what I typed at the command line, and that should be it. Now, I could add some environment variables too. I am running in development here, so I probably want to copy those environment variables that I had from the other one to set development. So I say ASP.NET Core environment, set that to development, okay, which is what you get by default for the other ones. And now, if I go up and hit Control F5 to launch without debugging on .NET Watch, it's going to launch .NET Watch for me. Here it is. I'm running from the console rather than through IS Express. And the exact same thing should work. So if I go to Hello Sydney works. I come over here, change it back to Hello World. If I look at my console, I can see stuff is recompiling, which is nice. Come back to the browser, and Hello World is changing. Okay, so here's how you can get that same sort of development workflow if you're not using IS Express for any particular reason, whether you're from the command line or whether you're doing it in Visual Studio. Okay. Ooh, loading PCLs. Who has portable class libraries? Okay, one, two, three, a few hands. Who references portable class libraries via NuGet? even if they're not building them? Okay, a few more hands go up. Yeah, not that many. Okay. Is everyone here just like doing .NET Framework and nothing else? They don't ever use PCLs? How many people don't really know if they're even referencing a PCL? There we go. Okay, so with the advent of .NET Core and .NET Standard, there is, unfortunately, have you ever seen that XKD comic where they talk about the way to fix the problem of 14 standards is to create a new standard, then you end up with 15 standards? We're kind of in that situation right now. There are many, many different PCL profiles. We have invented a new platform called .NET Core, which is now a new PCL profile, but because of the way PCLs work, it's actually a proliferation of new profiles because of the combinatory factors. And so in an effort to solve that, we've invented this thing called .NET Standard, which is probably easy to think of as just the next generation of PCL. So if I am running on .NET Core, because I want to run on Linux or I want to get some of the other benefits of .NET Core, but I need to load assemblies that were compiled before .NET Core was out, or compiled not for .NET Standard, but for some PCL portable profile, how do I go about doing that? Well, if I was just to try that, I might find myself in a little bit of trouble. So I know for a fact that there is the Google NuGet package for talking to YouTube, which I use. It's this one over here, google.apis.youtube version 3. I'm going to try and load that into this project that I just created. This project is using .NET Core, okay? And I know it's using .NET Core because under frameworks, it's using that .NET Core App 1.0 TFM, or Target Framework Moniker. It's just a fancy name for saying, this is the name of the framework I want to run on, okay? NuGet uses that TFM to decide which DLL outside of the NuGet packages that I reference up here to load into my application. And if there isn't a DLL that matches that TFM, or matches a TFM that is compatible with this TFM, there's a whole hierarchy of compatibility here, then you'll get an error, which I should get right now. So if I go ahead and try and restore this, it says it's completed. Let's have a look in here. Wouldn't it be funny if they'd actually fixed it and this won't fail? Which I wouldn't be surprised if they had. Let's have a look. I'm expecting this to fail, and it's not failing, which is surprising. I wonder if this is one of the ones that would give me a runtime error. Let's have a look. What happens if I try and call one of these APIs? Let's have a look. It should be client factory. Let's create a new one of these. I'm going to see if this fails. My God, they fixed it. That makes my demo not work at all. That's unfortunate. I am going to go and get to the bottom of this. So how would I figure this out? Well, I'm going to go back to the source of truth on my machine. I'm going to go to NuGet. I'm going to find this package. Here it is here. I'm using this version here. Here's the lib folder. Ah, look at this. This is interesting. So it looks as though, oh, hang on a second. The templates are already set up to make this work. So if I look at what's going on in this NuGet package, it has two portable profiles listed in its lib folder. Some big long strings, all right? I don't know how humans are supposed to understand what all these mean. You cannot just build these by hand, okay? Don't look at this and think, oh, I can just put together 4 random versions of .NET and it will work. It does not work that way. These all map to concrete profiles that are stored away on your hard drive in a magic location. And if you try and just build a string here using what you think you want to run on, it generally won't do what you think it's going to do. Now, the templates are actually set up by default, and this is the fact that I forgot, to override this problem. So down here under frameworks, under my TFM, they have this import statement. And it says, I want you to go and import these other 2 TFMs. So if I was to remove that one, and then I was to run restore again, which is doing for me automatically, now I get a failure, okay? And if I look at the error list, apart from the fact I have a compilation failure, You can see NuGet package restore failed for one or more packages. Please see the details in the output window. So, okay, and it's even been nice enough to underline that in project.json for me. And it says, the Google API does not support framework .NET Core at version v1. So NuGet has said, I went inside the lib folder, I looked at those TFMs, they don't match the TFMs that you're using in your project, so I can't restore this package for you. If I do go to the output window, you will see a little bit more information down here. So it says this package here is not compatible with .NET Core app. And then it says these are the things that it says it's compatible with. So if you run into this error when you're trying to get your ASP.NET Core application to run on .NET Core, and it's some dependency in NuGet is saying that it doesn't support .NET Core app, this is your next step. Okay? Your next step is to go, well, these ones work, so let me try and pick this TFM and go back to my imports section and add that. This is an escape hatch. This is you telling the tool chain, ignore the errors, just go and load this assembly anyway. There's no guarantee it's going to work. All right? It might work, it might not. But at least this will get NuGet to restore for you, and then you can actually try and get the assembly to load into your application. Now, I know for a fact that certain numbers of these PCLs or these profile names are compatible with .NET Core app. We did the work to make them sort of map, and so most of the time this should just work for you. Other times you will have to go to an extra step to get the runtime of this application to work. And I want to point that out for you in case you hit this. Maybe you won't remember everything I'm doing here, but you'll remember one of these names and you'll be able to search for it. So there is a package that the .NET team have released called Microsoft.NET Core.portable.compatibility. And what this magic package does is do a whole bunch of fancy assembly redirects and type forwarding in order to make different versions of PCLs from our long sorted history of .NET work against newer PCLs and newer versions of the .NET framework, or things like .NET Core. Okay? And so if you find yourself in a situation where you pull in a package and then when you try to compile, you get object is not equal to object, or system runtime is not equal to system runtime, or something like that. Okay, who's seen those type of errors before? I can see some nodding, yeah. This package may fix this for you, okay? So this package may help you use packages that are on NuGet that haven't yet been updated for .NET Core or .NET Standard, but do have PCLs inside that NuGet package, okay? Now there is some documentation on how to use this up on the .NET Core docs site, okay? So if you do run into this situation, explore this and see if it'll fix it for you. I know for the Google API stuff, it does fix it. The Google APIs haven't been updated to explicitly support .NET Standard, but you can get them to work by using a combination of imports to get around the NuGet block and the .NET Core portable compatibility to get around the .NET Core runtime block. Okay. Ooh, configuration binding and reload. This is one of my favorite things that I don't think we talk about enough. Let me go over to we'll do it in here. We'll do a new application. I'm going to show you something that's set up by default inside our templates. So people know we have a new configuration system that we built as part of ASP.NET Core. It's under Microsoft.extensions.configuration. It's not tied to ASP.NET Core in any way. It's not tied to .NET Core. It's just a library. Okay? You can use Microsoft.extensions.configuration in any .NET Core application. It's compiled against Net Standard 1.3, I think, so it'll even work on older versions of .NET Framework. Okay? And it's essentially a way to do pluggable config from various sources. So where you'll see this the most is in our templates. At the beginning in the constructor of your startup, we have these API calls here. We build a configuration builder. We add sources. I add a JSON file, app-settings.json, set some flags. I add environment variables so that I've got stuff coming from the environment as well. And then I call configuration builder.build. I can also add from what we call user secrets, which is the ability to store config values in your user profile as a developer so that you don't accidentally check them into source control, which is generally a bad idea. And if you choose identity auth while you build your app, you'll actually have that in the template as well. One of the little things that you may not know about this is this flag here. The configuration system supports live reload. Okay, so while the application is running, you can get triggers given to you when any of the config sources that you've plugged in have changed, assuming that config source supports alerting you that there's a change. Now, for things that are file-based, like a JSON file, we can use a file watcher to be told when the underlying file has changed, right? Which is why reload on true is there. And then if I look at the configuration object after this, after I've called build, you can see, if I zoom in here, there's a couple of methods to do with reload. I can force a reload at any time, which will force the configuration object to reevaluate any of the sources that you've plugged in. Or you can get a reload token that will trip whenever one of the underlying sources says that there are changes that should be reloaded. Okay? So how is this useful? Well, let's do a really, really naive example of this so we can see this in action. So I know that app_settings.json has been marked as reload on change true. So let me use configuration app_settings.json to flow something to the app, and we can see it change while the application is running so that I don't have to recompile. One of the disadvantages, by the way, the reason why this is interesting is that the config system in .NET and ASP.NET previously, which was all based on the web.config file, what happens when you change web.config file? Reboots your application, right? And one of those things just, the application goes away and you get a new one. So this is kind of nice that we can support this. So I'm going to add my configuration root into the DI container so I can get it from the rest of my application. I'm going to pass that in here like so. Oh, look, it's already typed as that, so VS was nice enough to tell me I don't need to do that. Then I'm going to go to my view, and I'm just going to really cheat here. Rather than try and flow this through a controller or anything, I'm going to violate all types of solid principles and go straight into my view and just inject that directly into my view, like so. And I'll say I want that from the DI container, please. That's going to be in a different namespace, so I'll say using Microsoft.extensions.configuration, okay? And then I will echo out to the page, configuration, and we'll get some value. And we'll call it index message. Okay, so let me go and add that message off, or that property. So there it is, index message. Hello from app_settings.json. So what we want to see is that while the application is running, I can change this file and actually see that change come up. All right, so I've added that. If I hit Control F5, that's going to start the application. Wow, that's really zoomed in. There's hello from app settings. Okay, so if I come over here and I say changed, come back here and hit F5, it says it's changed. Now, you might be going, sure, Damian, but didn't you just spend like 10 minutes showing us before that when you change code in Visual Studio, it automatically does it? Okay, so I won't do that then. So let's, first of all, JSON files aren't included in what we track for changing, because it's not part of the compilation input. But just so I can really prove the point, I'll edit it in a different editor. Yeah. So I'll come over here. Let's open this thing in VS Code. All right. So we'll open that folder. And then I'll open my app settings JSON file. We'll pin this over here. I'll find my browser. So I will change this from VS Code. I'll save that. If I refresh the page, then it's changed from VS Code too. Okay, so the configuration system in ASP.NET Core supports this concept of live reload, which is kind of nice. Now, we actually use this in the templates by default, which you may not be aware of. If I go back, thank you, Visual Studio, that was helpful. If we go back and look down here in the configure method, when I build the logger factory, so this is the thing in ASP.NET Core that lets you log from your application, do tracing. Okay, this is the new logging system that we built. It honors a lot of the same principles that we have used in our DI system and in our config system. I can add providers or syncs, and we can plug in third-party providers like Serolog and Nlog and those type of things as well. When I'm adding the console provider, which is one of the ones that we ship, you can pass in a config section. And what is that useful for? Well, you can use config to, in the case of logging, to configure different aspects of the logging. So if I look at the app settings file and look at this logging section, you can see that under log level, I have this map of string to log level, okay, string that maps to the log level enum. And how is this used? Well, this is used to change how much your application logs when it's running. Now, to really see this, you have to, or by default anyway, it's easier just to drop down and launch the application directly rather than launching it through IS Express so that you can see these log messages come out to the console. So here they are. Here's my log messages coming out to the console, which is kind of nice. I've got some stuff that happens at application startup, and then every time I make a request, you'll see that I get a bunch of spew from the application telling me about what's going on. Now, we have a bunch of the stuff in ASP.NET Core and .NET Core logs through these interfaces by default. If you have Entity Framework in the application, you'll see your database queries show up in this log, which is kind of nice. But you can see at the verbosity level on the left-hand side, I'm currently seeing mostly info messages. Obviously, as any good tracing or logging system supports, you can dial these up or down. And that's what this file is doing here. So it's saying for anything that starts with system or anything that starts with Microsoft, set the verbosity level to information or higher. And then for everything else, set it to debug, which is like really, really high. You see lots and lots and lots of messages with debug. If I don't want to see so many messages, I could change this to warning, for example. And I'll change this one to warning. And then without restarting the application, so there it is there, if I hit F5, note I'm not getting anything now because I turned off pretty much all the tracing that was in my application by dialing it down to warning. I can come back here and go to trace, which is a ridiculous amount of information. And if I hit F5, then oh my God, it scrolls down 5 pages for every single request. So that's in the templates by default, if you haven't seen that already. So we're taking advantage of that library low config stuff. It's being hooked up through the logging system, and you can do a very similar thing in any of your common code or common subsystems that you use in your applications to react to changes in real time. If you want to store your config in a system other than the file, obviously you could write your own config provider. Maybe you store it in your database or something like that. And then if your database can push changes when things happen, you could also take advantage of that config reloading in a custom config provider as well, which is kind of nice. OK. What else did I want to show? Ooh, routing to middleware. So I'm assuming most people here are using MVC. OK. Has anyone ever wanted something quote unquote lighter than MVC for a small application? OK. But they wanted routing. Maybe you just want, you want to be able to do very basic dispatch, and you want to be able to grab, segments of the URL, get all the nice route patterns and those type of things, but you don't want the full ceremony of MVC. Well, there's another little thing that we haven't talked about a lot in ASP.NET Core, which is what we call route to middleware. So I'm going to come down here in my application, and we'll give myself some more room. We'll zoom in a bit. So I can say var. Well, I'll just do it in line. I can say use router, and I can say new route builder, control dot my way to glory, and I can say dot map, zoom in a bit so you can see this IntelliSense as it comes up. I can say map get, and I can say when happy route matches, I want you to go ahead and run this middleware. Context dot response dot right line, I need to pull in that extension method, control dot. I just trust that it's doing the right thing. I can't see it, but it's for yes, surely it's not doing anything wrong. And hello from happy route. Okay. How many am I in? There we go, and I'll say dot build to build my route table. And there we go. So now I have a router, and this is asking for the app, because it needs to be able to resolve services. What doesn't it like? Does not contain a request delegate. Oop. Template, request delegate handler. OK. I don't trust you. Not contain a definition for response. That's because I'm calling the wrong overload. My mouse keeps sliding down the lectern, which makes it really fun when I'm trying to get it to show me IntelliSense. OK. I will see if I can force this. I think it's having some trouble with the inference of my Lambda. Let's see if I can get it to call the right overload. And that's right, not right line. And it's right async, of course, because everything is async. OK, so this, see, and now after I did all that, incredibly helpful Visual Studio. So I can tell you what that was. See, now it works. Visual Studio, I don't know whether it's C#. I don't think it's C#. I think it's actually Visual Studio. If you have an error inside your async lambda, like I did there, I was calling write line instead of write async, the method overloading logic for the thing that you're passing the lambda to just goes to hell. And so it kept just trying to pick the first one instead of the one that actually matches, and then it sent me down that 1-minute happy path of thinking I was typing the wrong thing. All right, so this is the smallest middleware that you can have, right? It's just a delegate that's inline, takes the context, and then you can write directly out. So what I'm doing here is I'm using the routing system to put a router in the middle of the pipeline, and then use that router to dispatch off to a middleware delegate. So this is really, really lightweight, right? Let me run this, and I should be able to hit happy route, as long as I don't have any build errors. And of course, it's being used by another process because I have like a billion windows open. Let's try that. There we go. So there, and if I go to my happy route, OK, there's hello from happy route down there. But this is routing. This isn't just like dispatch based on path, all right? I can actually do more stuff in here. So then I can do, I want to capture an ID, but it has to be an int, and it may not be supported. We'll just do ID. I'm just not tempt the demo gods too much. And then I can get that route information out, just like I would be able to in MVC or something like that, by using some extension methods on HTTP context. So now I can say context.getRoute value for ID. All right? And maybe I can say hello from happy route. ID is blah. OK? So now if I go back, and again, I don't have to recompile because it's doing all that for me. Happy route shouldn't match. Maybe it will. Nope, there we go. There's happy route. I don't think that picked up my change. Oh, of course. And the same thing. Oh. It's just easier to use IS Express sometimes, because I didn't go through the work of setting up .NET Watch. OK, so let me go back to happy route, which doesn't match now because I added a route constraint, right? I said /ID and it has to be integer. So now let's go and do 1, 2, 3, and there's hello from happy route, ID is 1, 2, 3. So that's full routing. Routing is actually the middleware, not MVC. Okay? MVC is a route handler that plugs into routing, and routing sits in the pipeline as the middleware. So if you want to build a really lightweight framework that isn't MVC, then you can use routing and get all the benefits of routing, then do whatever your own dispatching is. Now, you probably don't want to have inline lambdas, or maybe you do. Maybe you've only got like 2 things. You can also, rather than doing it this way, I could add another route down here. And say .map get, and I can call the other overload. So I can say happy map, and then I can take in an application builder and build a subtree of my HTTP pipeline. And there I can use normal middleware. I can use typed middleware, so I can get DI to inject stuff in because our DI container is hooked up to the middleware pipeline and will activate middleware for you. So if I go to the other overload, the one that takes action of iApplication Builder, now I can basically build a sub-application that hangs off this route. Does that make sense? So then I could do iApplication Builder, and this is where I do have to qualify them. App, like so. And then in here, and I won't do app because I've already used that word. I'll use map. And then here I have a new pipeline. So I could have MVC hanging off my custom router inside the main one where MVC is, you know what I mean? Like you can like host the same thing multiple times. Because this is just, use static files, for example. I could put static files inside here, but would only apply if I routed via my happy map route. Okay? So if you want to build a super lightweight API framework on .NET Core, using that, I will pimp it on Twitter for you, because I'd love to see more people use the built-in router. It's super lightweight, and it has a lot of nice features. All right, that was my last demo. So I have 5 minutes for questions, if anyone has it. I have a question up the back. There was a microphone that was going to be run around, or you can just... yell it out and I'll repeat it.
In the output directory, there was no PDBs or anything like that.
So the question was, how does symbol loading work? Because I noticed in the output folder there were no PDBs. Like that one?
That one, but the references.
Oh, so we don't ship PDBs with references. We never have. Like we don't ship them in the NuGet packages, right? So generally what happens is if you want to do step-through debugging on stuff that we ship, you configure your symbol servers in Visual Studio to look at the Microsoft public symbol servers, but we haven't published symbols.
I was more thinking line numbers from crash dumps in production.
I see, but into our code base. Or into your code base.
Into the Microsoft code base.
Into the Microsoft code base.
Yes.
Yeah, we haven't shipped symbols for the .NET Core stuff yet.
Okay.
So as part of the work to make .NET Core run cross-plat, we had to build a new PDB type because the PDBs that we use to date are Windows PDBs. Yep. So now we have a new type called portable PDBs. And you might have seen that in the, if you use VS Code, you'll see that in the .NET New that comes out there. And we're still working through the process of figuring out how to do those type of things. That said, you can get line numbers and things on Linux with crash dumps with a bunch of scripts that the .NET team has made available. But I don't know where they are off the top of my head. Okay. But you should be able to find information on that on GitHub. Is there a hand over here? Did I see a hand? There's one right here. There's two here.
There was some news that project.json would be discarded and you would be reverting to some other method. Can you comment on that?
Yeah, so I mean, the official source for all that stuff, the question was about project.json and it being discarded and all the rest of it. If you go to the .NET team blog, that's where all the details about that are being kept up to date as we build it. The short story is, we are the project.json and the .NET Core project model was a unique thing that we came out of what we did in DNX. It doesn't use MS Build. So we got a lot of advantages. We built a lot of new things, but it doesn't interact or play well with the vast community of stuff that already exists for .NET, including aspects of Visual Studio. And so in the next version of the tooling, which will hopefully drop by the end of the year, we're moving back to using MS Build under the covers, but we're adding features to MS Build and to the C# project system that we use so that all the benefits that we got out of the project.json model, most of them, will come over into this new system. So you won't have to list the files in the project. You'll be able to edit the project file while the project is loaded in Visual Studio. We try and get IntelliSense for NuGet packages, et cetera, et cetera, et cetera. So yeah, that's really the short story of it. There are some more details in some of the blog posts on here with about the official message along that. And the team is working hard on that move right now. The goal is to have that be an automatic step. So once that thing is released, you'll open your project in Visual Studio. It'll automatically convert it for you. Or if you're using the command line, there'll be a command in the .NET CLI to convert the project for you to the CS proj as well. Another question here?
Two questions. First one is there any functional difference in running ASP.NET Core on top of .NET Core versus the full framework?
Okay.
Like, see, I don't have a case to run it portable on Linux and other things. Can I still continue that?
Yep.
Other things, what is the difference between like ASP.NET Core moniker and the .NET standard moniker?
Okay, so the first question was, what are the functional differences between running ASP.NET Core and .NET Core or .NET Framework? So the benefit you get for .NET Framework is here forever. It's going to ship in Windows forever. And if you need .NET Framework, you should absolutely use .NET Framework. The big benefit you get are cross-plat, which you just said that you don't really need. And two is the side-by-side capability. So the ability for you to be able to have different versions of the .NET Core framework, which was that folder I showed you, Microsoft.NET Core.app, have different versions of that on the machine at the same time so that you could have different apps using different versions of .NET very, very easily. The extension of that is that you can also bundle .NET Core inside your application if you want to have the absolute most sort of standalone isolated version of your application possible.
How is Microsoft going to do security patching with this model?
Great question. So how is Microsoft going to do security patching if now there's random versions of .NET? So the .NET XE host has a servicing mechanism built into it. And so there is actually a location on disk in a different place away from where the shared runtime is installed that the .NET host knows how to look into to see if there are new versions of the assemblies that you're about to load that may have been delivered via some patching mechanism. So on Windows, we can use that mechanism to do force pushes, just like we do today with critical updates. And then for other platforms, we're investigating ways that we would enable system administrators to patch a machine so that, say you're using some vulnerable version of MVC or something, 1.0.3, and we've done a release of 1.0.4, and we've considered it critical enough that we've made a machine-wide patch available for it, you'd be able to run a command that would patch that on your machine. Okay, so the important part is the mechanism is already in place. It's shipped in 1.0. We hopefully won't have any need to use it for a while yet, but we will be able to do force push on Windows if we have to. And what was the second question? You had another one?
The difference between .NET Core app moniker and the .NET standard library.
Oh, so the short answer to that is the .NET Core app moniker represents the .NET XE sort of hosting model. That's an application model, like it's a .NET Core console app, right? And the .NET Core app moniker relates to the Microsoft.NET Core.app folder on your hard drive, essentially. Those things are all wrapped up in one little app model. Net standard is the moniker that's used to write .NET code that runs on any .NET platform. And the version that you use is what will dictate how many different platforms can use it. Okay, so one really is for library authoring, and one is for building .NET Core apps. Okay, so my time is up. If you have any more questions for me, hit me on Twitter. I have to disappear now to prepare for my next talk. Within an hour, we're going to talk about Kestrel with John Galloway. But thank you very much for coming along. I hope you're using and enjoying ASP.NET Core. And if you have any other questions other than you want to put on Twitter, feel free to log them on GitHub as well. Thank you.